Section 9.2, Polar Equations and Graphs. In 9.1, we introduced polar coordinates, the relation between polar and rectangular. So just to remind you, if xy is in rectangular, r theta in polar, and we learned that x equals r cosine theta, y equals r sine theta. We learned that x squared plus y squared is r squared, and we learned that tan inverse of y over x is theta. Those four relations are important. We need them. In this section, we talk more about the equations and their graphs, the polar equations and their graphs. So let's start with something easy. How do we graph r equals number? So r equals number, and then we're going to see theta equals number. So r equals number, there are many ways to graph this. One way is to convert it to rectangular, because we're more familiar with graphing rectangular than polar. So by squaring both sides, and then replace this with x squared plus y squared is 4. So that gives me the equation of the circle. Recall on the side, the equation of the circle is given by x minus h squared plus y minus k squared equals r squared. Here we have the center h comma k and radius r. Radius r. So from this one, I can see that the center is 0, 0 and radius 2. Center 0, 0, radius 2. So we're going to plot this point 0, 0 and radius 2. So you're going to go 2 in all directions and then just connect them. So that's what we get. That's the graph of r equals 2. R equals 2. What about if we need to graph theta equals pi over 3. Again, there's many ways to do this. You can pick values to get r and theta, or take tangent both sides, tan both sides for this equation. And we get tangent theta, we know it's y over x, tangent theta, and tangent pi over 3 is the square root of 3. Cross multiply, we get an equation of a straight line that goes through the origin. So if you take x0, y0, x1, y square root of 3. So it's going to be a straight line that goes through the pole here. That's the graph of theta equals pi over 3. What about a different kind of graph? R cosine theta is 4. R cosine theta, that reminds me of x, right? X is 4. So this means you're going to graph x equals 4. 1, 2, 3, 4. It's not just a point, that's a line. It's a vertical line. X equals 4. It's 4 units to the right of the pole. That's what x equals 4 means. So always x equals number is a vertical line. Y equals number is a horizontal line. So those are the straightforward graphs. Now we introduce more graphs. We're going to look at those that they come in the form a sine theta. A sine theta. Okay, a sine theta. Now what is a? A is a constant, it's a number. It could be positive or negative. If a is positive, what's going to happen? And if a is negative, how the graph is going to look like? Okay, so for the first one, a is positive, the graph will always fall above the y-axis or the polar axis with diameter a. Okay, it's a circle with diameter a above the polar axis. If a is negative, it's another circle that falls below the polar axis, and has a diameter a, center, whatever that's going to be, 0, negative a. So if you can really know that it's going to look like this, it saves a lot of time. Otherwise, you're going to go through plotting points all the time. Let's look at an example. Let's say I want to graph r equals 2 sine theta. Notice a is 2, it's positive. So that's going to fall above the polar axis. So it's going to be a circle above the polar axis with diameter 2. So this means the center is 0, 1, like that. That's the graph, done with this graph. Or you might graph it. There are two other methods to graph this. We can multiply both sides by r to convert it into rectangular first, as we did in the previous section. The left hand side is simply x squared plus y squared. The right hand side is 2 times y. And then what we do, we subtract 2y on both sides. And then we are going to divide this by 2, which is 1. U squared, you get 1. So add 1 to this side and 1 to the other side. So that gives us x squared plus, these are y minus 1 squared is 1. So the center is 0, 1, radius 1. Center 0, 1, radius 1. So if you try to plot this, center 0, 1, that's 1, and radius 1, so you're going to go down 1, up 1. Next one. What about if we have a cosine theta? I think you can guess how this is going to look like. So depending on a, if a is positive or a is negative. So the sign was up and down, and always going to be like that. So either above the polar axis and or below the polar axis. Cosine will be to the right or to the left. So if it's r bigger than 0, it's going to be a circle to the right of the y-axis with diameter a. Another one, the less means to the left with diameter a. Let's look at an example. R equals negative 4 cosine theta. How do we graph this? Well, there are two ways to graph it. As I said, one way, first, I see it's a is negative, so it's going to be to the left, and the diameter would be 4. So R equals negative 4 cosine theta. Multiply both sides by r. Then this is x squared plus y squared equals negative 4. R cosine theta is x. R cosine theta is x. So then what do? We add 4x to both sides. So, or that's like a second method. What we need to do here is to complete the square. So now completing the square, how do you complete the square? You divide this by 2, you get 2, you square it, you get 4. So always add 4 and add 4 to the other side. So that's where we complete the square. That's an x plus 2 squared plus y squared equals 4. That's another circle. As you can see, circle with center negative 2, 0 and radius 2. And that's what the other one is. See, negative 2, 0, radius 2. The next one, what about if we have r equals? Now another form of graphs. R equals a plus or minus a sine theta. Do you see the a's are the same? And a must be positive. A must be positive. In this case, this is, the shape is called cardioid. Cardioid. And it looks like a heart, either heart or upside down heart. So there are two cases. The case when r is positive, the positive in the middle like so. And we're going to look at a minus a sine theta. So for the plus, let's see how that's going to go. For the plus is going to be a heart that opens up, so more toward the up, because sine either up or down. Plus means up, minus means down. And then it's going to go like this, upside down heart. And then how far do we go up to the right or left? You go a to this side, negative a there. And then what you always do, you add these two a's, a plus a, 2a, and that's what goes in there, 2a. And it comes down to the pole like that. With the negative, you flip this. We flip it. So it's going to be an actual heart like this. This is A, negative A, and that's negative 2A. So that's how we graph cardioids for sine. So let's say I want to graph or sketch a graph for r equals 1 plus sine theta. 1 plus sine theta. So how do you do 1 plus sine theta? It goes like so. Since it's a plus, is going to go up, and then you go 1 unit to this side, 1 unit that side, and 2 units up. So it starts here through this, and then back down. So that's 1, negative 1, 2. That's the graph. What about if we take another one? Graph r equals 2 minus 2 sine theta. See, this a minus. Minus means going to go down. But how far down? How far down? Well, it's going to go 2 plus 2 down. So it's going to go, let's graph it this way first. So let's graph it. So it's going to go 2 to the right side, 2 to the left, and 4 down. 1, 2, 3, 4. 4 down. So it's going to go this way. 2, negative 2, negative 4. That's the graph. What about if it's cosine? So now I think you can guess how the cosine is going to look like. It's going to go hard to the right or to the left, depending on the sign. If it's positive or negative. So if it's positive, it's going to go to the right. If it's negative, it's going to go to the left. So this would be like that. So this is 2A, this is A, negative A, A, negative A, negative 2A. Okay, and before I forget, you can always use Desmos to check the graph. So what I do usually, I change 2, 2 into 1, 1, 3, 3, and see how the graph changes. And same thing with any polar graph I do, I try to play with the numbers and see what changes does that make. So this is easy to graph. Another kind of figures we have the next graph called Limacons. Limacons. So what do we, how do they look like? Almost like a heart, but it's not. So let's look at the first form, the A plus or minus B sine theta. See, A is not the same as B. If A is the same as B, then you get the heart. If they are different, you get something called Limacon, which is, with this restriction, we're going to do it here. It doesn't have to be always like this. Just in this section, we're going to deal with it this way. 0 less than B less than A. So if I look at R equals 3 plus 2 sine theta, and how do I graph this? How do I graph this? First thing we do is, the way this is being graphed is this number here is going to be let's call it on the x-axis. This will go on the x-axis. This means you're going to go 1, 2, 3, 1, 2, negative 3 on the x-axis. If you take the 2 together, 3 plus 2, 5, that's going to be on the y-axis. So 1, 2, 3, 4, 5 on the y-axis. And then it's not at the origin anymore. So what you do, you take that 3 minus 2. So it gives you 1. And also on the y-axis. So, but it's going to be down here. So then the graph would go straight, looks like a circle. And then it's going to go down a little bit, then up, then down, and then up. That's called Limacon. So that's like a negative 1, 3, negative 3, 5. That's Limacon. What about if it's negative? R equals 3 minus 2 sine theta. Same concept, but it's going to be, see how it's on the y-axis because it's sine. If it's cosine, it goes on the x-axis. Here, because it's negative, it tells me it's going to be, it's going to fall below the polar axis. The graph will fall below the polar axis. The plus up there was the graph falls above the polar axis. So now what do we have? We have the 3, 1, 2, 3, negative 1, negative 2, negative 3. And then down 5, 3 plus 2, 5, because it's going to go down. 1, 2, 3, 4, 5. And then 1 up here. So it's going to go like a circle. And then it's going to go a little bit higher than this, then down, then a little bit higher, and then it goes this way. So that's a 3, negative 5, negative 3, 1. That's how we graph limicons. What happened to the cosine? Okay, now you can kind of guess it's going to go right and left all the time. So if you have r equals a plus or minus b cosine theta, same condition, b must be less than a and both positive. Both positive. So then what we get here is going to go to the right or to the left. So let's say we're asked to graph r equals 3 minus 2 cosine theta for this, and I'm going to graph 3 plus 2 cosine theta. So the minus indicates, this minus means to the left, So you're going to go this, now this is on the y-axis. 1, 2, 3. In the cosine, that's on the y-axis. And you go down negative 3. And 5 here, 1, 2, 3, 4, 5. And so, and 1 here, because 3 minus 2 is 1. So it's going to go like this, like a circle. Then it's going to go a little bit out to this, and then out to this. 1, 3, negative 3, negative 5. For the next one, that's a positive, so this means it's gonna fall on the right side. 3 plus 2, 5. 1, 2, 3, 4, 5. 3 up, 3 down, and 1 here. So again, it's gonna go like a circle, a little bit outside this, down, and then a little bit out through this all the way up. 5, negative 3, 3, negative 1. So this is important to know this way, because otherwise if you plot points, it will take a lot of time to do it that way. And here it's not easy to convert this into rectangular coordinates. The last part we're gonna do is those that they come in the form a sine 2 theta, like the double angle one, a sine 2 theta and a cosine 2 theta. In this case, a is going to be always positive. We consider it positive all the time. Those are going to look like a rose. We call it with 4 petals. 4 petals. So how does that look like for cosine, for example? Let's say r equals 3 cosine 2 theta, and we're going to see r equals 3 sine 2 theta, the difference. Always the number of petals will be double, because this is even. It will be double this. If it's odd, it will be the same. But here in this section, we'll only focus on the 2 theta. But in general, if that's because that's 2 theta, that's even. The number of petals is going to be 4. Same thing in this case, going to be 4 petals. How does it work with cosine? With cosine, the petals falls on the axes. So they fall like this. That's the first one. The next one, they're going to be 4 of them. Third one and the fourth one. In this case, they fall in the middle of the quadrants. So 1, 2, 3, 4. Okay, now the question is like how far, what does that 3 do in the front? The 3 tells us how far it goes up. So this distance is 3, this is 3, this is 3, 3. And here the same thing, this distance is 3, this distance is 3, this distance is 3, this distance is 3. That's how we get the petals. So if you change that 3 to 2, it will make it smaller one, but the location will be the same in both cases. If you change the 3 to 4, will be the same location, but the barrels will look bigger because the kind of like, let's call it the diameter of the barrel will change. So this is, let's call it, this is the diameter of the barrel. Same thing with the other one, diameter of the barrels. So these are guidelines basically, like if you have this, do it this way. If you have this, do it that way. So in summary, what we have those straightforward ones like r equals number, theta equals number, or r is given in terms of sine or cosine, like here. These ones, this one, r cosine, either r cosine or r sine equals number. Those are going to be either a horizontal line or a vertical line at the end. And the other one's easy to convert to rectangular. That's why we worked it out nicely. Now, in case you have r equals a sine or a cosine, you can still convert them to rectangular and do it from there. Or if you like, because the whole section depends on the same concept. If you're dealing with sines only, it goes up or down depending on a. If you're dealing with cosine only, it's going to go right or left depending on a. So that's what we did here. And we did it in two different methods. If you convert into rectangular, what happens? And if not, what happens? And then the next part of graphs that we see is called cardioids. The cardioids, that's when a equals a, the same. A are the same. And always a is going to be positive here. So if it's a plus and you're dealing with sine, it's going to be a heart that opens up. If it's minus, opens down, another heart. Opens means it's directing down. But if it's cosine, what happens is go to the right or to the left. If it's a plus, means to the right heart, minus to the left heart. Limacons, we have, that's when a and a does not equal a. So a and b are not the same. Specifically b less than a. If b bigger than a, which we do not want to go over in this section, it will look totally different. It will look different. There's more into it. And then we saw how we actually go through graphing them as I change these numbers, 3, 2, 4, 5, or 5, 4. How does the graph look like? Well, always in the case of sine, again, it's going to either open up or down. And then the first number goes on the x-axis. In cosine, the first number goes on the y-axis. And then 2 plus 3 gives me how far it's going to go on the y here. In the cosine, 3 plus 2 tells me how far I'm going to go on the x. And the last one is about the roses. That's when we have double angle formulas or double angle function, like sine 2 theta, cosine 2 theta. That will give us always 4 barrels. Those, for the case of cosine, are going to be on the axes. For the case of sine, are going to fall in the middle of each quadrant, as you can see here. Again, Desmos is very important to go back and check your answers. You can play around with these numbers, trees, and change them, see what happens. If you change, let's say 2 to 4, you're gonna have, you end up with 8 barrels, like double, always double the number inside the theta. If it's 2 theta, you got 4. If 4 theta, you get 8. If it's 6, you get 12, and so on and so forth.